Hello to myself and everybody else. This is video 137. So far this time, we're still looking at stuff from the 31-hour free code camp video. And so far for this one, we're looking at stuff related to polymorphism and inheritance at different levels. And so far, this is a very, I'm just going to say it, a straight up ignorant example, because this is around 15 files long. And it really does not need to be. But so far, again, just go ahead and run through this so I can just have the code for future use if I need it. So far, again, here's a main CPP file. I'll go ahead and just scroll down. Here's animal.h, animal.cpp, feline.h, feline.cpp, dog.h, dog.cpp, cat.h, cat.cpp, bird.h, bird.cpp, pigeon.h, pigeon.cpp, crow.h, and crow.cpp. Again, so far this was very long and it takes forever to type out, but at least I got a copy of this on video if I ever need it. But yeah, basically the whole thing is this. So far, basically this is the main parent class, animal, and from that main parent class at the very top, wait, let me go. Yeah, the main parent class at the top, it branches off into two children, which would be feline and into bird. And then so far, feline branches off into two more children that inherit from feline, which would be dog and cat. And then bird, which is a child of animal, that has two children, which would be pigeon and crow. Basically, that's the whole thing with this and everything as well. Just basically just showing all that. So that's really the whole thing and stuff with that too. And basically the main.cpp file was basically just showing that with polymorphism and inheritance, you can basically branch things off. So polymorphism work in a very specific way. So like with this and everything too, at the very top right here, we have we have animal polymorphism, which let me go ahead and comment everything below it out so we can just kind of see how this looks. Alright, so for our animal polymorphism, basically we have a dog, cat, pigeon, and crow, all that set up and everything as well. And again, we have a pointer and an array with the pointers inside of it. And then we have it print out so far the function breathe that's inside of it. And again, so far breathe basically says animal, breathe called for, and then whatever animal and stuff it is too. So basically feline has the, well, it's not in the other ones. Let me see it. Yeah, we have breathe and stuff here too, and dog and all that, and various things like that. But yeah, so far we're just going to run this. So far, again, we can see that it called breathe for, dog, cat, pigeon, crow, called it for everything. Because so far, again, with animal at the very top and the children at the very bottom, which would be dog, cat, and pigeon and crow, those are basically children of other children, which basically inherit from animals. Kind of hard to show, like without a diagram. Basically, again, animal at the top, that's a parent to, has basically two children, feline and bird, which then they have more children, which would be dog, cat, and crow and pigeon. And based from there, just showing that again, from the animal polymorphism, that everything kind of inherits stuff from there, and just kind of show that off. Let me go ahead and do this. And I'll just do it like this here. So far, feline polymorphism, which contains dog and cat. So far, it's showing that again, we're making a pointer and basically have an array with both of the pointers inside of it. And basically show that we can also do it like this as well. Basically saying feline can pass stuff off to dog and cat, and we can still like print the information. We're going to be using run. And so far, run inside of it, let's just go and look and see. Run just basically says feline and then description. And inside of the dog, same thing, just says dog, description, and in cat. Run here says cat and then description. So again, we'll just run it. I also have bird polymorphism there too, but yeah, hold on for a second because it has the other thing. Yeah, it's basically that now, right? There we go. So basically shows that dog and cat can also print out that they're running and everything. It basically says that, again, it's showing that polymorphism can work and inheritance can work very specifically because, again, feline, the two children it has is dog and cat. So that's why this works. If it tries to inherit or run anything from pigeon, it will not work. So pigeon.h over here, again, it doesn't have run in it whatsoever. So it didn't inherit any of that stuff. It's inheriting from bird, not feline. And let's see real quick in bird. Bird only has fly. It does not have run whatsoever. It didn't inherit run. So if we try to add pigeon inside of this, it would crash. So basically I can just show that off too. So just put a comma, that, and put pigeon 2. So I'll just try to run it. And so far it doesn't work. Again, it says error, cannot convert pigeon to feline in initialization, because again, it isn't inherited any of the information from feline. So basically just goes to show we can just be very specific when it comes down to just inheritance and everything. So again, to go back to feline. Again, basically has the information and everything here and stuff like that too. Is virtual, so be used for polymorphism. Then dog, and inherits from feline. And basically contains the virtual function and everything too that can be overwritten. Same thing with cats. It has virtual and override. Has same function, everything. Inherits from feline. While the bird itself, not bird, but pigeon, it inherits from bird. It does not have the run function whatsoever. So that's why I wouldn't work with this. And so far, just show the same thing with the bird one as well. So we just kind of make sure and see that this works. So right here too, bird polymorphism, again, same thing, pigeon and crow, using bird pointer and everything, printing everything out. So again, using fly function inside of it. So run it this time. And right there again, pigeon, fly, called bird, pigeon 3, called bird, and crow 3. Again, just showing you can set up just like polymorphism to work with specific things, basically just going more into inheritance and everything, and just inheriting functions and making sure certain things inherit stuff and other things don't. So that was kind of just the whole point of like this part of the video and everything. So far the next part and everything basically talked about inheritance with polymorphism using static members. And basically so far this part of the video, he basically just talks about using a keyword called static. And he says he basically showed us what this did before, which that's not true at all. So far, again, I think just like with the free code camp video, I think wherever they got these videos from, they didn't get all of them. Because so far, there's just like some things he'll talk about that he said he showed before that's completely not true. I don't have it in my notes. They're not there. So just some of the stuff we just have to kind of bear with and just kind of see what's up. So really with that, just like again, I just kind of like basically copied as much stuff as I could, took notes, just kind of see what I could do. But so far, again, here's the code and stuff for this and everything. So here's the main.cpp file. Then here's shape.h. Then here's shape.cpp. Then here's ellipse.h. And then here's ellipse.cpp. And basically so far with this, like I said before, the main thing and stuff he kind of shows in this is a keyword and everything that he used. If I can go ahead and find this in here. So far, give me a second. I'll see if I can find it. Okay, I see it. Yeah, so right here, static. So far, basically what static does is it basically keeps whatever number it is consistent. So basically, like in this right here, we have like looking at, well, let's look at the base parent class. We have shape, a default constructor. Then we have, you know, another thing in here too, shape, base text string description. We have the deconstructor and everything, a function called draw. Basically, the main thing we're focused on is basically just like the constructor and deconstructor. And basically the static int mcount. So if we go over to the CPP file, basically again in the constructor and everything stuff here too, where it says string view description, it basically adds 1 to the m count, and then basically with the deconstructor it takes away 1. Basically again with this, it should just be kind of consistent, just going through it. Like this is the exact same thing too in ellipse.cpp. Same thing, static int m count, everything like that as well. And basically over here too, just showing like with inheritance and polymorphism and everything. So like in shape over here, we have shape 1, we have shape count and everything stuff as well, which will print 1. A second object called shape 2, and again it'll print out a thing too called, it'll print out the m count as well, which would be 2, then 1, 3. Same thing. Let me go ahead and just comment some stuff out real quick so we just kind of like see everything one piece at a time. So yeah, we're going to run this. See, so far, going to print out everything as 1, 2, and 3. And I messed up one thing here too, because kind of cutting it off. But either way, it prints out 1, 2, and 3. And so far, the whole thing with that is basically just showing that again with static. Once it does in here, the constructor, it adds 1 with that object. Then next object, it adds 1, because already 1, that'll become 2. And then with the third object, since it's 2, we'll add 1, making it 3, so it stays consistent. So no matter what the number and stuff is, it would just keep staying that way and everything too. So if we made another object, it would become 4. It wouldn't repeat. Like if we didn't make it static, then each one it would just be 1. But because we set it to static, it's adding a number, keeping that number, and then the next one, it's like, okay, it was that number before, do whatever it said to do. So like add 1, and it'll keep adding it. It'll stay consistent because it's static. So that's the main thing stuff with that too. So if I uncomment this, let me do it like this. And let me comment the stuff out above it. There we go. So far with ellipse and everything and stuff too, basically the same thing as well. So let's just print out the m count and everything and stuff too. So let me do this real quick. Yeah, because since I comment this stuff out up here, it's just showing that shape count is 1. And that shape count is 1 here as well. Let me uncomment this. So again, we can basically just kind of compare and everything too. So with the top part commented out, so our shape is 1. But up here, again, as you said before, it keeps it consistent. So it was 3. Then we add another object. It'll become 4. And ellipse, since this is the first one, it should be 1. So again, just run it again. As said before, again, 1, 2, 3 for shape. Then we make another object, it's 4. Ellipse count, it becomes 1. So that's basically just showing like the static and everything and stuff there as well. This part down here at the bottom, this is another thing where he kind of said before, he was like, he showed us, like I'm trying to remember what he called it. Basically another thing kind of said he showed, but he really kind of didn't. I might be mixing my stuff up here, but basically, again, I'm just going to run this real quick so we can just see what this does. Yeah, basically just showing the same thing with the count and everything and stuff too. Just like, again, it keeps the numbers consistent and everything too and all. Just basically, again, like with this, using shape and all that, and we're basically making an object shape 1, ellipse 1, and from there just saying like, again, shape is 4 because it was consistent with that, and ellipse is 1 because we only had 1 ellipse object stuff made, so we're just kind of printing that out again. But that was really it, just kind of showing that again, you use static, basically just to summarize it. Use static, the number will just stay consistent between each thing. So if you add 1 to it, make a new object, it will stay whatever number it was before, and things like that. That's the main thing of it. So that was really all I got from this part of the video. So to myself and everybody else, see you in the next one.